Did we do this slide?
No, we did not.
All right, so this is just, I mean, you guys know this, but to the names for the changes of state. Okay. When we add heat, like we did yesterday, to a system in when we change a liquid to a gas, we may call it boiling or evaporation or vaporization. They all mean the same thing. When we cool,
When's our test?
Friday-ish,
Oh, that's so soon.
we'll see. When we remove heat from a system, actually maybe not Friday, we change a gas to a liquid. What's the term for that? Matthew? Condensation. If you continue removing heat and the matter changes from a liquid to a solid, yeah? Freezing or solidification. But sometimes certain types of material can skip a phase. Okay? It's called sublimation in both directions. Something changing directly from a gas to a solid is called sublimation, and the opposite is also true. Something changing from a solid directly to a gas.
So, liquid is basically the middleman.
Sort of. It's an in-between phase from one to the other.
Like, what would go from a gas to a solid?
A gas to a solid, like dry ice, is formed by compressing carbon dioxide, and eventually it forms a solid.
But if a cloud, gases don't have anything holding it together.
Yeah, no.
What about a cloud? Maybe ungas?
Well, cloud is water vapor condensing often on smaller particles in the air. So that's I think why they stay together, because they're on particles in the air. They're in clusters in the air.
Is cloud considered solid then?
No, it's water vapor. Water gas.
So, okay.
Well, with droplets of water as well.
Could you drink it?
A cloud?
Yeah.
Wait, isn't it kind of a cloud like really, really cold?
When you fly your Pegasus up there, you can just watch out for the unicorns. Yep.
If you set your hand in a cloud, wouldn't it like freeze? Like not like the actual like freeze, but isn't it like really cold?
No, not necessarily. It depends on the elevation.
Skydivers don't.
All right, so let's look at a heating chart. So we're gonna look at a bunch of diagrams like this. Okay, this is a chart, and this chart is showing you a solid. Okay, that's you're adding heat to. So as time goes on, as we saw yesterday, what happens? What happens when this graph flattens out here? Victoria?
It stays the same.
Well, the temperature does stay the same. What's going on there? How do you think we would label that section, Sarah? So what word would we use? Melting.
Okay.
So, I guess at first we have solid there, a liquid in the middle, and then a gas. And the steps in between, melting and vaporization. And so what you notice that when a substance is changing from one state to another, its temperature remains constant. And that's what you guys experienced yesterday when you're recording the temperature of that snow. As long as there's some solid in there mixed with the liquid, it's going to stay at the same temperature, 0, until it's completely melted. The same is true of the liquid until it completely turns into a gas. The opposite is also true. So you're going to get, what state of matter do you think this starts with?
Gas.
Gas.
Or solid. Or solid. Liquid gas.
Okay, when you remove heat, the same thing happens. You're removing heat until that gas is completely, what word do we use? Yes. Condensed into a liquid. It will stay the same temperature. And then when it's completely liquid, then the temperature will start to drop. Eventually it gets to the freezing point, and then the temperature levels off again. As that liquid is turning into a solid, its temperature stays the same until it is completely a solid. So here, so this slide just shows the same thing. If we go in, the bottom shows adding heat. So if we add heat to a solid, it gets warmer until it gets to the melting point, and then it melts. And it's a liquid, which warms up until it gets to the boiling point, and then it boils. Once it's all boils, it gets to a gas, and it warms up. And the opposite, cools, condenses, cools, freezes, cools. So what is the melting point of ice?
0 degrees.
What's the freezing point of water?
32 degrees.
0
That's
0 degrees
Fahrenheit.
Celsius.
Oh, well, yeah. I'm sorry.
32 degrees Fahrenheit.
It's 0 degrees then.
So 0 degrees Celsius is the melting point and the freezing point?
No,
Yes.
no, wait a minute.
water-
Yes.
One degree and melting
Wait,
point.
can I repeat the question?
What is the melting point of ice?
Oh, it's 0 degrees, okay, yeah.
What is the freezing point of
0
water?
degrees. I got it.
So how could they be the same?
Because it depends which way you're going.
Depends on whether you're adding heat or taking heat away. Okay? If you're adding heat to ice, it begins melting at 0. If you're taking heat away from liquid water, it starts to freeze at 0. All right.